We're studying the lesson Motion in One Dimension, and today we'll be studying about speed and velocity. We'll understand more about speed and velocity. Let's understand a little bit about speed before we go into the depth of understanding speed. Let's say that there is a car and this car is traveling. It's moving fast. Okay, and this car, let's say that it is moving at 250 km per hour. Okay, it's quite fast, right? So by this we understand that what is speed then? Speed is the quantity by which we will know how fast a body is moving. In this case, how fast the car is moving. So speed is the quantity by which we know how fast an object or a body is moving, or we can say that how fast it is traveling. Like this car is traveling at 250 km per hour. Let us understand about velocity in simple sense. Okay, now same like speed, the car is moving very fast. Okay, it is traveling very fast. And in this illustration also, let us say that the car is traveling at 250 km per hour, but there is a difference here to understand velocity. You have a compass, you can see on the right hand side of your screen, this car is traveling at the speed of 250 km per hour. In which direction? Eastward. It is traveling in east direction, right? So by this we understand that velocity is the quantity by which we know how fast the body is traveling or the body is moving, and we also know in which direction, in a certain direction. So this is what velocity is. In velocity we know how fast it is moving and in which direction it is moving. I hope you understood the difference between speed and velocity here. Let us understand more about speed. Okay, we'll understand more about speed here. The speed of a body is what? The speed of a body is the rate of change of distance with time. The speed of a body is the rate of change of distance with time. In the illustration that I showed you before, distance 250 kilometer, time hour, right, per hour. And numerically, it is the distance traveled by the body in 1 second. Okay, that's what speed is. And speed is a scalar quantity. You know, we have learned about scalar quantity. Speed is represented by the letter lowercase u or lowercase v. And how do we find speed? Probably this is just a revision for you. You have already learned this in your lower classes. Okay, speed. How do we find speed? Speed is equal to distance by time. Distance is symbolized by capital S and time is symbolized by small lettered t. Okay, now you have to remember that displacement also is represented by capital S. And how do we know the unit of speed? Unit of distance by unit of time. In this example, unit of distance is kilometer and unit of time is hour, right? That's why it is called as kilometer per hour. I hope you're understanding this. Okay, and the SI unit of distance, SI unit of distance, you already have known it before, we have studied about it. SI unit of distance is meter, represented by small letter m, and time is second, represented by small letter s. So the speed of the SI unit of speed will be meter per second, right? You see, we're just connecting to what we have studied before, meter second or meter per second, and the CGS unit of speed will be centimeter per second, right? We have got this meter per second from the SI unit of distance and SI unit of time. That's how we have found the SI unit of speed, meter per second, and the CGS unit of speed is centimeter per second. I hope you have understood till here. Now let us study more about speed. Let's see what is uniform speed. Okay, let's see what is uniform speed. Let's say there is a volleyball. Okay, it's rolling on the floor. Okay, a volleyball moving on a floor. Now this is a single volleyball. Okay, this is not 4 volleyballs. I've just represented moving at different distance. Now here is what I want you to understand. You are seeing 3 different instances or 3 different locations of a single volleyball, right? And all of these are separated by equal distance, 1 meter, 1 meter, and 1 meter. And when the volleyball started to roll, to reach 1 meter, it took 1 second. And from that second point, when it rolled another 1 meter, it took it 1 second. And likewise, to reach the 4th point, it again took 1 second. So here the distance is same and time interval is same. So a body is said to be moving with uniform speed if it will cover equal distance in equal intervals of time. Now you see that equal distance, 1 meter. It is traveling 1 meter at equal intervals of time. So this is what uniform speed is. Equal distance is 1 meter, 1 meter, and 1 meter. Okay, and each interval of time is same, 1 second, 1 second, and 1 second. So it has, in 1 second it covers 1 meter in each instances. Then is when we can say that a body is moving in uniform speed. Now, knowing the uniform speed of a body, we can also calculate the distance moved by the body in certain interval of time. Okay, so we can also calculate the distance. Distance, you know that the symbol is capital S, is equal to, what is the lowercase v representing? Uniform speed, and t represents time. So when we know the uniform speed and time, we can also calculate distance. I hope you understood that. Let's see what is non-uniform speed or variable speed. Let's say that there is a volleyball rolling on a plane surface. Okay, we're talking about non-uniform or variable speed. Now you see that volleyball at the initial point is moving on the plane surface, but you will see here that the distance covered, all right, I'm representing the distance covered is not same, but what is same here? The time interval is same, right? Initial time is 0 second, then in 1 second, then 2 seconds, 3 seconds, 4 seconds. In initial time it's 0 meter distance. In 1 second it has covered 2 meter distance, right? Then again in next 2 seconds it has covered 5 meter, right? So the difference will be 3 meters now. And in the next 3 seconds it has traveled 11 meters, right? That would be 6 meter. So now you see here that the interval of time is same, but the distance covered is different, right? So a body is said to be non-uniform or variable speed if it covers unequal distances, right? You see that it is traveling unequal distances in equal intervals of time. When you see on the screen, you will see that the time interval is same, right? 1 second is the time interval. But if you calculate the distance covered, you will notice that the distance covered is not same, right? So I hope you have understood what is this non-uniform or variable speed. Equal intervals of time, 1 second is the time interval, but distance is not same in every time interval, right? So that is what non-uniform or variable speed is. Now in case of bodies moving with this non-uniform or variable speed, we specify their instantaneous speed and the average speed. Let me show you an illustration. Let's say that a boy is coming back to his home, maybe after the school or maybe after playing, and at the start he is running at a speed of 10 km per hour. Okay, and after, let's say after a few minutes, he got a little tired and the speed at which he is running has become less, 7 km per hour, right? And when he's reaching close to his home, he's more excited, right? So his speed has increased again. He's running at 12 km per hour. Now by this, what do we understand? When the speed of a body keeps on changing, variable, that's what variable is. When the speed of the body keeps on changing, like initially he was very excited, he wanted to reach home quite early, then he slowed down, then again he became very excited, and then he started running at 12 km per hour. So when the speed of a body keeps on changing, its speed at any instant, any point, is measured by finding the ratio of the distance traveled in a very short time interval to the time interval. This speed is known as instantaneous speed. Instantaneous speed. I hope you have understood this. You can go back through the video and see it again. Now, how can we calculate instantaneous speed? Distance traveled in short time interval divided by time interval. The distance that he covered is 2 kilometers, okay, from his playground or from his school to his home. Now, for example, the speedometer of a vehicle measures the instantaneous speed, right? This is one of the example. You can see the speedometer. I hope all of you have seen a speedometer. It doesn't remain the same. It depends on the traffic, right? It might be 10 km per hour or 80 km and again reduces to 20 km per hour. Let's understand what is average speed. Okay, let's say that there's a motorbike and this motorcycle has to cover 600 kilometers in 8 hours. Okay, so the distance that it will travel or it has traveled is 600 kilometer and it has taken 8 hours. So average speed, how will we calculate it? Total distance traveled divided by total time taken. That is how we calculate average speed. Total distance traveled by total time taken. Now if a body is moving with uniform speed, okay, if it is moving with uniform speed, then the instantaneous speed and the average speed will be same. Okay, it will not differ because the speed is uniform. I hope you have understood till here. You can go back through the video and see it again to understand it much better. Keep learning and keep studying.